Today we're going to talk about how to compare fractions with different denominators. We will go over 3 methods you can use to compare fractions. We will convert fractions to equivalent fractions. We'll use cross multiplication. And finally, we can look at the decimal value to decide which fraction is greater. In math, we typically show a comparison of something by using the greater than, less than, or equal to signs. Let's use those signs to figure out how to compare two sets of fractions. When you see two fractions that have the same denominator, it is very easy to evaluate which fraction is greater. Let's look at the example of 1/10 and 3/10. Because both denominators are 10, all you have to do is compare the numerators in each fraction. 3 is greater than 1, so 3/10 is greater than 1/10. But what happens when you have two fractions that have different denominators? Well, it becomes more tricky. I'm going to show you a few ways that you can evaluate them to see which fraction is greater. The first method we're going to go over is to use equivalent fractions. Let's look at the example of 2/5 compared to 3/8. Both denominators are different. However, we can create new fractions that are equivalent to these and then do our comparison. The easiest way to convert both of these fractions into equivalents is to find the least common multiple or lowest common multiple. The lowest common multiple of both 5 and 8 is 40. Let's find an equivalent fraction for these using the denominator of 40. For help on finding equivalent fractions, check out my video on that. I have a link in the description. 2/5 can be converted into an equivalent fraction of what number over 40? By looking at how many times 5 goes into 40. The answer is 8. 8 times 5 is 40. To make equivalent fractions, what you do to the top, you must also do to the bottom. So 2 times 8 would be 16. We then write our first fraction over again to be 16 over 40, as it is equivalent to 2 over 5. Let's convert our second fraction. Look at our denominator and see how many times 8 goes into 40. The answer is 5. Let's multiply our numerator times 5 and we get 15. Our new equivalent fraction is 15 over 40. Now that we have the same denominators, it's easy to see that 16 is greater than 15, so looking at our original fractions, 2/5 is greater than 3/8. One more example, converting to equivalent fractions. Which one is greater, 7/16 or 3/4? Since we have different denominators, the first thing we would do is find the lowest common multiple. 4 actually goes into 16, so we can rewrite 3/4 into something over 16. 7 over 16 just stays as 7 over 16. 4 goes into 16 4 times, so then we multiply 3 times 4 and we get 12. 7/16 compared to 12/16. 12/16 is greater. Now, building on that same concept that we just went over, let's look at it from a standpoint that basically shows the same thing, but it's a little faster to compute. 3/5 compared to 4/7. We can see that the first thing we need to do is put both denominators into its lowest common multiple. The lowest common multiple in this case would be 35, as 5 times 7 equals 35. When you see that the lowest common multiple is simply the two denominators multiplied by each other, you can skip converting the fractions to equivalent and just use what they call cross multiplication. Cross multiplication in this instance is going to be multiplying the numerator of one fraction by the denominator of the other fraction, and vice versa. The first step would be to multiply 3 times 7, which would give us 21. This is going to be our new numerator. We would put this new numerator next to the numerator we just multiplied it by. In this case, it would be next to the 3. We would next multiply 5 times 4, which is 20. This is the numerator for our second fraction. We can say that 3/5 is greater than 4/7 because 21 is greater than 20. But let's convert these to equivalent fractions just to prove that our theory works. Converting 3/5 to an equivalent fraction, the denominator of 35 would be 5 goes into 35 7 times. 3 times 7 is 21. 7 goes into 35 5 times, and 5 times 4 is 20. If you went and did the full steps of finding equivalent fractions, you would have seen that 21 over 35 compared to 20 over 35. Since the denominators are the same, we can simply evaluate the numerators to find the largest fraction. All right, let's move on to our last example on how to compare fractions, but this time we're going to use the decimal method. Fractions themselves are nothing more than division problems. 2/5 is the same thing as dividing 2 by 5. Remember, when your numerator is less than your denominator, you know that your decimal will always be less than 1. Remember that in case you accidentally divide the wrong numbers incorrectly. Looking at the same example we had last time, 3/5 compared to 4/7. We can use division to set the problem up like this. 5 goes into 3. Using the long division process, you would get 5 goes into 3 0 times. Put our decimal points down and add a 0. 5 goes into 30 6 times. Also, using a calculator, you would get an answer of 0.6. Let's set up our second fraction the same way. 7 goes into 4 0 times. Add our decimal point and add the 0. 7 goes into 40 5 times with a remainder of 5. And we can add another 0. 7 goes into 50 7 times, and you can go on and on. I can already tell that the number is 0.57 in other numbers, which is less than 0.6. So I'm going to stop there and say that 3/5 is greater than 4/7. As you can see, we are taking concepts that we have already learned, such as finding equivalent fractions, turning fractions into decimals, and cross multiplication, and we are now applying them to help us evaluate which fractions are greater. If you would like more practice with evaluating fractions, head on over to my website at improvedmath.com and check out the free practice problems and answers. If this video helped you out, then help me out. Click the like button and hit subscribe. Thanks for watching.